We've got a mass volume density question here. We've got a toy which is shaped as a cone and a hemisphere. They're bolted together. They create a toy with a mass. We're told the mass of each toy, and we're told the density of the material from which the toy is made. And we've got to find out a relationship between X and Y. So first of all, density is equal to, well, it gives it here, mass divided by volume. Just writing that down as a reminder. Okay, let's look at the volumes. This is volume 1 of the cone, and this is volume 2. So volume 1 is a cone, and that's equal to 1/3 pi r squared h. So putting in terms of our diagram, this is 1/3 pi, r squared is x squared, and h is y. Volume 2, a sphere is 4/3 pi r cubed, but we've got half of it, so this is divided by 2. So again, putting that in terms of what we've got here, this will be 2/3 pi, and the r again is the same, which is x cubed. So going back to the question, we've been given the mass, we've been given the density, so we can work out the volume. So the volume from what the question says, V, is equal to mass over density. Its mass, we're told, is 100 pi, and the density is 60. And we're in grams per centimetre cubed. Just check that everything is in grams. Occasionally questions will shove in a kilogram or a metre and try to trip you up that way. The zeros cancel, and we're left with 5/3 pi. Again, hugely recommend you stay in fractions. So we now can say that the combined volume here and our calculated volume here must be equal. Right, cancelling fest. All the divide by 3's go. All the pi's go. Dividing through by pi all the way. What are we left with after that carnage? And the question wants us to express y in terms of x. So all we've got to do is make the y the subject. So therefore, this term isolated, x squared y is equal to 5, which remains effectively undisturbed, but it's joined by minus 2x cubed. And dividing through by x squared, I get y is equal to 5 minus 2x cubed divided by x squared. And there's your answer.